Hello everyone, welcome to my YouTube channel. Myself Gagan from Sri Venkateswara College of Engineering from the CSE branch. Today I'm gonna take a topic from the microcontroller and embedded system. Today we are gonna discuss about what is data processing instructions, what are the types of data processing instructions, and there's some examples and barrel shifter and example. What is data processing instruction? Data processing instruction can be used to manipulate the data within the registers. These are the fundamental and arithmetic logic operation of the process that operates the value in the general purpose register and immediate value. Multiple and divide instructions can be considered as a special case instructions. Data processing instructions mostly use one destination register for two source of operand. The general form of data processing instruction, that is introduction, RD, RN and operand, where RD represents the destination register. Most of the data processing instruction can be processed one of their operands using a barrel shifter. Here on the right hand side you can see the figure, that is R02, R20, that is as a general purpose registers, R13 that is a stack pointer, R14 is a link register, R15 is a program counter, and the CPSR, current processor status register, that is N2 we called as conditional flags, IF called as interrupt marks, and processor mode. Types of data processing instructions: move instructions, arithmetic instructions, logical instructions, compression instructions, multiple instructions. Move instructions. Simplest form of ARM instructions copies the N into the destination registers, that is RD, where N is the registers of where N is the register. Useful for setting the initial value and transferring the data between the registers, and followed by syntax. Here in the table, M move a 32-bit value into the registers. MVN means move the not of 32-bit value into a registers. This is example for the move instruction. The move instruction takes the contents of register 5 and copies into register 7. In this case, the taking the value of 5 and overwriting the value of 8 in the register R7. In pre R5 is equal to 5, R7 is equal to 8. Move R7, comma R5, post R5 is equal to 5, R7 equal to 5. We can conclude that the value of R5 is moved to the R7 of the register. Arithmetic instruction. The arithmetic instruction mainly implement the addition and subtraction for 32-bit signed values as well as unsigned values, followed by syntax. ADC means add with 32-bit values and carry. ADD means add 32-bit values. RSP means reverse subtract of 32-bit values. RSC means reverse subtract of carry of 32-bit values. SBC means subtract with carry of 32-bit values. SUB means subtract to 322-bit values. This is the example for the arithmetic instruction. The simple subtract instruction subtracts a value stored in register R2 from the value stored in register R1. This is a result stored in R0. In pre, R0 is 0 before execution. R1 is equal to 2, R2 is equal to 1. By SUB, by subtracting R1 and R2, we can in the post R0 is equal to 1. This is the output above the instruction moved into the R0 register. Logical instruction. Logical instruction can perform a bitwise logical operation on the two source registers, followed by syntax and logical bitwise of two 32-bit values, ORR. Logical bitwise OR of two 32-bit values, EOR. Logical exclusive OR of two 32-bit values, BIC. Logical bit clear. This is the example for the logical instruction. The example shows the logical OR operation between the register R1, R2, and R0 and holds the result. R0 holds the result. In pre, R0 is equal to 0 before the execution, R1 is equal to 20400608, R1 is equal to 10305078. Oh, by performing an OR operation, R0, R1 and R2, therefore in post R0 is equal to 1, 2, 3, 4, 5, 6, 7, 8. Comparison instruction. Comparison instruction can use it to compare a test registers with 32-bit value. They update the CPSR bits according to the result but do not affect the register. After the bits have been set, the information can be used to change the program by using the conditional execution followed by syntax. CMN means compare negated, CMP means compare, TUQ means test equality of two 32-bit values, TST means test bits of 32-bit values, where N is the result stored in shift operation. This is an example for the comparison instruction, where R0 and R9 is compared and the post CPR is equal to output is generated after the comparison. Multiply instructions. Multiply the contents of a pair of registers and depending upon the instruction accumulate the result in with another register. The long multiplies and accumulate onto the pair of registers representing the 64-bit value. The final result is replaced on the destination register, that is RD, on the pair of register or a pair of registers. Followed by syntax. MLA means multiply and accumulate. MUL means multiply. So there is another for operation, that is SMLAL, signed multiply accumulate long, SMULL, signed multiply long, UMLAL, unsigned multiply long, and SMUMULL, unsigned multiply long. The long multiply instruction can produce a 64-bit result. The result is too large to fit a single 32-bit registers. So the result is replaced in the two registers, that is labeled RD and RDLO and RDHI. RDLO holds the lower 32 bits and of the 64-bit result, and RDHI holds the higher 32 bits with the 64-bit result. This is the example for the multiply instruction. The example represent a simple multiply instruction, so it multiplies the R1 and R2 together, places the result in registers R0. That is R0 is equal to 0 before execution, R1 is equal to 2, R2 is equal to 2, and multiply R0, R1 and R2. R0 is equal to R1 into R2. By multiplying R1 and R2, we can get the result R0 is equal to 4, R1 is equal to 2, R2 is equal to 2. These are the operands R0 and R2. A barrel shifter. It is a device to shift a word of variable amount. It is one of the logic device used to pre-process one of the operand or registers before operating on the ALU operations, and it is one of the best main feature of the ARM. Mnemonics. LSL, logical shift left. LSR means logical shift right. ASR means arithmetic shift right. ROR means rotate right. RRX means rotate right extend. These are the end shift operations, that is immediate register, logical shift left by immediate, logical shift left by register, logical shift right by immediate, logical shift left by registers, arithmetic shift by immediate, arithmetic shift by register, rotate right by immediate, rotate right by register, rotate right by extend. This is an example for the barrel shifter. This is an example of the moves instruction. Shift registers R1 left by 1 bit, and this multiplies the registers R1 by the value of 2 power of 1. In pre, R0 is equal to 0, R1 is equal to 800004. Moves R1, R0, R1 and LSL. Post R0 is equal to 00008, R1 is equal to 8004. The C flag is updated in the CPR because S suffix is present in the instruction mnemonics. Conclusion. In this video, we have learnt about what is data processing instruction and types of data processing instructions, and with some examples, and barrel shifter, what is barrel shifter, and with some examples. Thank you for watching this video. Please like and subscribe. See you soon in the next video. Thank you. Take care. Bye.